So I'm hoping to keep this video really quick. This is about finding the angle of intersection between two lines. So the idea is if you want the angle of intersection between two lines, it's going to be the same as the angle between the directional vectors of those two lines. And so one thing I have to say here is that I hope you guys remember how to find the angle between two vectors. We use the dot product for that, right? We remember, hopefully, that the dot product of A and B is equal to the magnitude of A times the magnitude of B times the cosine of the angle in between them. So if you want to find the angle between two vectors, you use the dot product and plug it into this formula. So the idea is if they ask you for the angle of intersection between two lines, all we have to do is find the two directional vectors of those lines and find the angle between them. Now, as a note, in order to find the angle of intersection, this sounds silly, but the two lines, they have to actually intersect in order to have an angle of intersection. Now, IB's not going to trick you. They're not going to say, find the angle of intersection between these two lines, and the answer is, haha, they don't intersect. If they're going to do that, they're going to set they're going to set the problem up first. I feel like the way they're going to ask this is first they're going to say, find the point of intersection, and then now that you have the point of intersection, you know they intersect, which means they can ask you for the angle of intersection. Okay? So, long story short, all we need to do, if you're asked to find the angle of intersection between two lines, is find the angle between the two directional vectors. So when you're looking at these two lines here, what are the directional vectors here? Hopefully you remember that the directional vectors are this guy and this guy, right? So how am I going to find the angle between them? Well, again, I'm going to use my formula. A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle in between them, right? So remember how we do the dot product. For the dot product, we're multiplying the x parts together plus the y parts plus the z parts. Hopefully you will find that the dot product of these is negative 17. So negative 17 equals the magnitude of A, which is the square root of, and remember how this works, this is 1 squared plus 3 squared plus 4 squared. That should be the square root of 26 times the square root of, the other one, we've got the square root of 29, times the cosine of the angle between them. So then we do our division trick. We end up with, not even division trick, we use division. Cosine of theta is negative 17 over the square root of 26 times 29. For me, that ended up being, let's see here, ended up being negative 0.61, 61, that's just ugly. I'm missing my stylus today, so things are a little bit messier. 619. So then when I did inverse cosine, I'll give the answer in two forms. I ended up first with radians, which was 2.24 radians, and then I converted that into degrees, and so I got that was 128 degrees. So either one of those would be acceptable answers for this problem. So long story short, if they ask you to find the angle between two lines, just pull out the directional vectors and find the angle between them using this formula. On the next page I have an example for you guys that's one step up. So for this one, I'm asking us to find the angle of intersection of these two lines. And you'll notice these two lines I did not give to you in vector form. So what you're going to need to do is you're going to need to convert these things into vector form. I hope you guys remember that the way that we do that, this was covered in one of the previous videos, is write it in y equals mx plus b form, and then pull the slope and the point off of that to rewrite it. I'll do this one for you as an example, and that way you guys can do the other one on your own. So when I rearrange this, 4y is negative 3x plus 27. Then when I divide by 4, y is negative 3/4 x plus 27 over 4. So that means this line in vector form would be, well, first the point. The point that we have is this y-intercept. My y-intercept is 27/4, and for as much as that's messy, it turns out I'm going to ignore it later anyway. This is going to be 27/4 0 plus t times, now the directional vector, remember if you have a slope, we change that into a directional vector by writing it upside down. So I'm going to put 4 and negative 3. Now, you might have decided to put the negative with the 4 instead of with the 3. It doesn't matter. It's not going to make a difference, so don't worry about that. Okay? So now I'd like you guys to do this line over here. Take this line and convert it all the way down to vector form just like we did over here. So that should be negative 2y equals negative 5x plus 3. So that means y is 5 halves x minus 3 halves. So that means my line will be negative 3 halves 0. That's my point that's on the line. That 3 looks kind of ugly, but again, we're going to be ignoring it anyway. Plus s, or t, doesn't matter, times the vector 2, 5, because we're supposed to take the, sort of flip this over to get those two values. Okay? So now that I'm at this point, we want the angle between these two lines. That means I want the angle between these two directional vectors. Right? So again, I'm going to go into my dot product method for that. First, we have the dot product of these two vectors. The dot product is 8 minus 15 equals the magnitude of the first vector, that's root 29. The magnitude of the second vector, that's square root of 25, which is actually 5. And then the cosine of theta. So if I simplify it up with negative 7 over the square root of 29 times 25 equals the cosine of theta. Then I do my inverse cosine. I ended up with theta being 1.83 radians, which was the same as, let's see here, it was 105 degrees. So again, either one of these answers would be acceptable unless the problem asked for degrees, which is common on the IB exam. One last example for you. So these lines are perpendicular. You're being told that they're perpendicular. They want you to find the value of k. Well, if the lines are perpendicular, it means that they meet at a right angle. It means the angle between them is 90 degrees. That means that the angle between the directional vectors is 90 degrees. Those vectors are perpendicular, and you should know what to do with that. I pause the video now, work through that. You should remember that if vectors are perpendicular, it means their dot product is 0. So that means that negative 20 plus 2k plus 3k has to be 0. So that means, that means that 5k is equal to 20, which means k has to be 4. So the moral to the story in this entire video, this entire lesson, is that if they ever talk about the angle between two lines, find the directional vectors and look at the angle between those. And that's all I have to say.